Welcome to this puzzle session. Here is the problem. Let a and b be positive integers. Select more than half of the integers from 1 up to a plus b. So this is a list of integers. Suppose we select more than half of them. Then we want to show that two of the selected integers will differ by either a or b. So amongst any selection of more than half of the things here, one can find two of them which differ by either A or by B. Very interesting puzzle. You can play around with it by substituting specific values for A and B and check its veracity, and in the process perhaps arrive at a proof. And of course, you are encouraged to pause the video and find your own proof before we look at what I'm going to discuss. Okay, so with that, let us look at the solution. I will show two solutions, in fact. So here is the first and a very elegant solution of it. So we have written numbers from 1 up to a plus b in the top row in a somewhat permuted fashion. And we have also written numbers from 1 up to a plus b again in a different permuted fashion. So first we write 1, 2, 3 up to b. Well, this is not permuted at all, actually. So the first row is not permuted at all, while the second row is permuted. So here we have 1 up to a starting from this point and then continuing here. So it's kind of a rotated copy of the previous one. Alright, and now suppose what we do is we mark out all the integers that we have selected. Okay, so we have selected some integers, some set S. Okay, we have selected some subset of integers from here. So in the top row we mark out all of them, and in the bottom row also we mark out all of them. We maybe put a cross on them or something, or maybe put a tick if you like. And the point is this. Because of the way they are paired, just observe that before this big vertical bar, the difference of any two of them is b. Of course, the absolute value of the difference. And in the right side of the vertical bar, the difference of any two of them is... in the left side, the difference of any two of them is a, and the right side, the difference of any two of them is b. And here is the point. If S has size more than half of a plus b, then since we are marking every integer that is there in S above and every integer that is there in S below, how many numbers are we marking out? We are marking out at least twice of, in fact, exactly twice of S numbers, and that is strictly greater than a plus b. Okay? So these many numbers we are marking out, and that is greater than a plus b. But how many how many such things are there? How many pairings are there, so to say? Exactly a plus b, right? Exactly this much. So since there are a plus b cages, if you will, and more than a plus b pigeons, some two pigeons must share a cage. In other words, we will necessarily mark two things which are in the same column. This you may call the pigeonhole principle or common sense. More than a plus b things are marked, and there are only a plus b columns, so one is forced to mark two things in some same column. Some column must witness two marks. So if that column is amongst these, then the difference between two of them is a, and if that column is amongst these, then the difference between those two of the marked things is b. So therefore, there exist two marked things which differ either by a or by b, which is same as saying that there are two selected things which differ either by a or by b, and that finishes the proof. It's a very elegant proof. And now let us look at the other solution, which I will not discuss in detail. I'll just show you. You can pause the video and read it. So this is the solution. It's more complicated and somewhat more ad hoc, perhaps not so amenable to generalization if one likes to generalize it. But anyway, it's a solution. With that, I want to end this lecture. As usual, like, comment, share, subscribe, and I will see you next time.